Have you ever wondered how complex systems or patterns emerge from simple interactions in nature? This is a phenomenon known as emergence in nature, and it's more common than you might think. You see, emergence is the process through which simple interactions at a microscopic scale can lead to complex, often beautiful systems and patterns at a larger scale. It's a bit like a cosmic dance, where each performer knows only their own steps, yet together they create a synchronized ballet of epic proportions. From the way proteins fold into intricate structures to the formation of galaxies far beyond our reach, emergence is a key player in the symphony of life and the universe. It's the silent director, orchestrating a multitude of interactions to create a harmonious, interconnected whole. So, prepare to be amazed as we venture into the world of emergence, where simplicity births complexity. Let's dive deeper and explore some fascinating examples of emergent phenomena, starting from the microscopic level. At the microscopic level, an incredible example of emergence is protein folding. Proteins, the workhorses of our bodies, start as simple chains of amino acids, but it's not their sequence that defines them, it's their shape. Each protein folds into a unique three-dimensional structure, a transformation that's both spontaneous and intricate. This process is governed by the properties of the 20 amino acids, each with its own distinct characteristics. Some are attracted to water, some repel it. Some are positively charged, others negatively. And it's these characteristics, these simple interactions, that guide the protein to its final form. Like origami artists, proteins fold themselves into a dizzying array of shapes. Spirals, sheets, loops, all meticulously arranged. And it's this shape that determines a protein's function, whether that's defending against invaders, speeding up chemical reactions, or carrying messages between cells. So the complexity of protein structures emerges from simple amino acid interactions. Moving up the scale, we encounter cellular differentiation in multicellular organisms. Now, what's fascinating about cellular differentiation is how it's a remarkable example of emergence in biology. Just think about it. We start with a single fertilized egg cell, and through a series of complex interactions between genes, signaling molecules, and environmental cues, this cell multiplies and specializes. Each cell in your body, whether it's a nerve cell, a muscle cell, or a skin cell, started as the same initial cell. But through cellular differentiation, these cells take on different forms and functions. Genes are switched on and off. Signaling molecules are sent and received, and in response to these cues, a cell transforms. It becomes specialized, designed to perform a specific function in a specific location. From these interactions, the incredible variety of cell types in our body emerges. It's an extraordinary dance of nature, choreographed by the principles of emergence. In the brain, another fascinating example of emergence is the formation of neuronal networks. The brain is a universe within itself, populated by billions of neurons, each connected to thousands of others. These connections create an intricate network that is the foundation of our thoughts, memories, and consciousness. But how does this network form and function? It's all about the interactions. Each individual neuron communicates with its neighbors, sending and receiving signals in a complex dance of electrochemical activity. It's through these constant interactions that complex behaviors and cognitive processes emerge. Think about it. Every thought you have, every memory you recall, every decision you make, is the result of countless neurons interacting and communicating. It's a process that's happening right now as you listen to this, your brain interpreting these words as meaningful information. Consciousness, memory, and thought all emerge from these neuronal interactions. It's a testament to the power and beauty of emergence in nature. Shifting our gaze to the animal kingdom, we see emergence in flocking behavior. It's a captivating spectacle, watching a murmuration of starlings in the sky or a school of fish in the ocean. But have you ever wondered how these complex patterns form? It's not as though there's a conductor orchestrating their movements. In fact, each bird or fish merely follows a few simple rules. They maintain a certain distance from their neighbors, they align their direction and speed with those nearby, and they move towards the average position of their local flock or school. These interactions, devoid of centralized control, lead to coordinated movement and predator avoidance. It's a beautiful example of how individual components operating under simple rules can give rise to collective behavior that's far more complex. However, it's not just about the aesthetics. This emergent property has evolutionary advantages too, like predator confusion and energy conservation, which contribute to their survival. Thus, flocking behavior emerges from simple interactions between individual birds or fish. In urban transportation systems, traffic patterns provide an example of emergence. Picture a bustling city street, each vehicle navigating its own path. Like cells in a body, individual cars, bikes, and buses interact, creating a larger, more complex system. It's not unlike a dance, where every participant has their own rhythm, but together they form a pattern. Sometimes this pattern leads to a smooth flow akin to a well-choreographed ballet. Other times, the dance is more chaotic, resulting in traffic jams and congestion. These phenomena are not dictated by a central authority, but emerge spontaneously from the interactions of individual vehicles. Each driver's decisions, when to brake, when to accelerate, which lane to choose, contribute to the overall flow of traffic. A single car slowing down can ripple through the traffic, creating a wave of brake lights. It's a fascinating display of how simple individual actions can culminate in complex collective behaviors. So the chaos of traffic emerges from the behavior of individual vehicles. In the atmosphere, weather patterns show us how emergence works on a larger scale. These patterns are not random, but rather the result of intricate interactions between air masses, temperature gradients, and Earth's rotation. Hurricanes, for instance, are born from the dance of warm, moist air rising and cooler air descending. This cycle creates a rotation, fueled and intensified by the heat of ocean waters. Tornadoes, on the other hand, emerge from severe thunderstorms when warm, humid air collides with cool, dry air, producing powerful spiraling winds. Jet streams, too, are products of emergence. They form high in the atmosphere where air masses of differing temperatures meet, creating strong winds that circle the planet. Each of these phenomena, though vastly different, are all born from the same basic elements interacting under varying conditions. Complex weather patterns, then, are emergent phenomena. Within ecosystems, biodiversity, nutrient cycling, and population dynamics are examples of emergence. Let's delve deeper. Ecosystems are a complex web of interactions between various species and their environment. These interactions give rise to the rich tapestry of biodiversity we see around us. Every creature, from the tiniest microbe to the largest whale, has a role to play in this intricate dance of life. Turn your attention to nutrient cycling. This is the process by which essential elements like carbon, nitrogen, and phosphorus are exchanged between organisms and the environment. It's a grand, unseen ballet of chemistry, a constant exchange and transformation of materials that supports all life. Population dynamics, too, is an emergent phenomenon. The rise and fall of species populations are influenced by factors such as predation, disease, and food availability. These dynamics are not governed by any one entity, but emerge from the collective actions of all organisms within the ecosystem. Thus, the stability or fluctuation of ecosystem states emerges from these interactions. In the world of finance, fluctuations in economic markets are an example of emergence. Much like the ripple effects triggered by a single stone thrown into a tranquil lake, changes in stock prices, supply and demand, as well as market trends, emerge from a complex web of interactions between investors, traders, and economic indicators. Consider the stock market. The price of each share doesn't exist in isolation. Instead, it emerges from countless interactions and decisions made by investors and traders, all influenced by a myriad of economic indicators such as interest rates, inflation, and economic growth forecasts. Similarly, market trends don't just materialize out of thin air. They're the aggregate result of individual investors and traders interpreting and reacting to a broad spectrum of information. From company earnings reports to geopolitical events, every piece of information can influence the decisions made within the market. Markets' behavior then emerges from these financial interactions. In human societies, emergence manifests in the form of social networks. Social structures, cultural norms, and group dynamics are not merely a random product of individual actions. Rather, they emerge from an intricate web of interactions between individuals. When we interact, we do more than just exchange words or gestures. We exchange ideas, values, and experiences that shape our understanding of the world and our place within it. Picture a room full of people. Each person is unique, carrying their own set of beliefs, knowledge, and experiences. As they interact, they influence each other, subtly shaping the room's collective mindset. This is how social structures emerge. From the repeated interactions of individuals, cultural norms and group dynamics develop, each influencing and being influenced by the other. These emergent phenomena are not static. They evolve over time, responding to changes in individual behaviors and broader societal conditions. Social hierarchies, cooperation, and collective action all emerge from these individual interactions. In cities, emergence can be seen in urban form and land use patterns. It's a captivating dance of interplay where the choreographers are urban planners, developers, and residents, each contributing to the city's evolving shape and rhythm. Economic forces, like invisible puppeteers, also pull the strings, influencing where we live, work, and play. Imagine a city as a living organism. Just as cells interact to form tissues and tissues form organs, individual buildings and streets come together to form neighborhoods, and neighborhoods form cities. Each component, whether a high-rise building or a humble park, is part of a larger, complex system, contributing to the overall function and feel of the city. The social interactions that occur within this urban milieu are also emergent. A spontaneous street festival, a bustling farmer's market, or simply the daily ebb and flow of pedestrians, all are examples of social behaviors that emerge from individual actions and decisions. The built environment and urban dynamics, therefore, are emergent phenomena. On a global scale, climate systems provide an example of emergence. Let's consider the El Niño Southern Oscillation, or ENSO for short. This is a recurring climate pattern involving changes in the temperature of waters in the central and eastern tropical Pacific Ocean. But how does this emerge? Well, it's all about interactions. Interactions between oceanic and atmospheric circulation patterns, greenhouse gas concentrations, and solar radiation. Oceanic and atmospheric circulation patterns are in a constant dance, exchanging heat and moisture. This interplay is then influenced by the levels of greenhouse gases, which trap heat and affect temperature balances. Solar radiation, the energy we receive from the sun, also plays a critical role in this intricate system. These factors come together in a complex ballet, giving rise to global climate patterns like ENSO. It's a testament to how seemingly separate elements can intertwine to create something greater, something emergent. Regional and global climate variability then emerges from these interactions. Finally, at the grandest of scales, emergence is seen in the structure of the universe itself. Consider the formation of galaxies, galactic clusters, and cosmic filaments. These awe-inspiring structures don't just materialize out of thin air. They emerge from a cosmic dance between dark matter, baryonic matter, and the omnipresent force of gravity. Dark matter, an elusive substance invisible to our eyes and instruments, provides the framework upon which galaxies are built. Baryonic matter, the stuff you and I and everything we can see are made of, clumps together under the pull of gravity, forming stars, planets, and galaxies. These galaxies, in turn, cluster together, forming vast cosmic filaments that weave a web across the universe. Each level of structure, from galaxies to galactic clusters to cosmic filaments, emerges from the interactions at the level beneath. The large-scale structure of the cosmos, then, is an emergent phenomenon. From the microscopic to the galactic, emergence is a fundamental aspect of nature. We've journeyed through the fascinating world of emergence, witnessing its magic across various scales. From the intricate dance of protein folding, where the three-dimensional structures of proteins are born from the interactions between amino acids, to the awe-inspiring formation of galaxies created by the interplay of dark matter, baryonic matter, and gravitational forces. We've observed the emergent in multitudes as cells differentiate into specialized types, as neurons network to create consciousness, as birds flock and fish school, as traffic flows and weather patterns form. We've seen how ecosystems, economic markets, social networks, cities, and climate systems all display this remarkable phenomenon, with complex systems arising from simple interactions. Emergence is the symphony of nature, a testament to the interconnectedness of our universe. Next time you observe a complex system or pattern, remember it's probably the result of simple interactions giving rise to something greater. That's the beauty of emergence.